Took a swing at a wrecking ball and I prayed for my downfall, and I found a way to reconcile, 'cause in my heart it's not worthwhile.
Say you were given two numbers to add. You got 79.495 plus 26.37, and you're told to add both numbers. If you go ahead and type this in a calculator, your answer will be 105.865. Even though this is the answer you got from the calculator, it would be wrong based on the laws of significant figures. So what you would do, you would look at the number with the least decimal places, and that's the amount of decimal places you should have in your final answer. So here, this has 2 decimal places. So what you could do, you could draw a line here to show that here in your final answer you should have 2 decimal places. So when you're writing your answer, you have 105.8. Now because the 6 is followed by a 5, you would round up to 7, giving you 105.87 for your final answer. And this rule goes for subtraction as well. Say we use the same numbers, 79.495, and you are subtracting 26.37 from it. I would get 53.125 if I type this in a calculator. Now the same will go for this. So this number has 2 decimal places. So I would draw a line here, and I know I would have 2 decimal places here. And because this is a 5, I would round this up to 3, so I would have 53.13 for my final answer. So both subtraction and addition, the rules go for both. Now say I was given 25.34 to be multiplied by 72.29. If I plug this in a calculator, I would get 1831.8286 for my answer. So 2 numbers, and both have the same number of significant figures. So I know that my final answer should have 1, 2, 3, 4 significant figures in it. So that's the difference between addition and subtraction and multiplication and division. In the multiplication and division is the amount of significant figures in the number with the least amount of significant figures. That's what your answer should have. So here in both numbers we have 4 significant figures. So in my final answer I should have 4 significant figures. So if I go ahead and write my correct answer, I would have 183, and because this 8 is greater than 5, I will round this to 2, and that would be my final answer with 4 significant figures. Now say with the same question I was told to write this in standard form, I would have 1.8, which is between 1 and 10, multiplied by 10 raised to a power. How do I know which power? I move the decimal place 3 places to the left to get it where the point is in 1.832. So I know now that I have 3 for the index. Let's do a next multiplication with different numbers. So say I have 29.754 and I have 60.05. Yes. And I'm supposed to multiply both numbers. If I go ahead and put this in my calculator, I would get 1786.7277. When you're multiplying or dividing, the number of significant figures in your final answer should be the number of significant figure in the number you're multiplying with the least significant figure. So let me say that again and say that better. So when you're multiplying or dividing, how you know the amount of significant figure in your final answer? You look at the numbers you're multiplying. You look for the one with the least number of significant figures. In this example, the 60.05 has the least significant figures. It has 4 significant figures. So my final answer again should have 4 significant figures. So when I go ahead and write my final answer, I should have 1780. Now this is a 7 greater than 5, so this should raise to 7. So that's my final answer. And again, if I'm told to write this in standard form or scientific notation, I write first the a. Remember from the last video, a times 10 to the n, where a is a number between 1 and 10. So I'll write this in a form where it is 1.787, which is a number between 1 and 10. So 1.787. Then I multiply it by 10. So times 10 raised to a power. How do I know which power that is? I shift the decimal place in the original number. So from here, that's where the original decimal point would be, and I shift it 1, 2, 3 to get this number here. So I know that this would be a 3 for the index. Let me do 1 division and then that's it. So let me divide 1385.9574 divided by 805.83, and I'm dividing this. I should have wrote. Okay, I'm dividing this. If I type this in a calculator, I would have 1385.9574 divided by 805.83. My answer would be 1.719912885. This is the answer I would get if I put this in a calculator. But I know you know that the number of significant figures of the number with the least significant figures, that's what should be in the final answer. So we can see that in this 1, 2, 3, 4, 5 sig figs. So the final answer should have 5 significant figures. So let's go ahead and write the final answer. 1.719. That's 4 significant figures. And for the last one would be an x9. But this is 1. So we would write back the 9 as is. So let's say you are told to write this in standard form. You might be saying, no, that can't be written in standard form because it's already in its lowest form. But actually you can write 1.7199 times 10 raised to the power of 0. Any number raised to the power of 0 is 1. So a raised to the power of 0 equal 1. So that's it for this video. Thank you for watching.
Took a swing at a wrecking ball and I prayed for my downfall.